All right, so the testing. I told you earlier that I put a backing piece behind the chest piece just as a belt and suspenders type approach to make sure it didn't penetrate. They shot the chest piece with a .22 caliber, a 9mm. They didn't tell me they were going to do a .45. They just said 9mm, so I wasn't there for the ballistic testing, but this is the .45. It made a reasonable dent, but it did not break through the titanium surface, so that was cool. And then a golf ball size piece of C4 at a meter distance away. What they did in this case was they put they assumed that a pressure wave of 75 psi would be considered lethal. So they got their diaphragm burst discs that if they see anything above 75 psi, they will rupture. So they put one inside behind the suit, and they put one just outside the suit, both at a meter away. You can't see it in this still capture from the video, but the one inside the suit didn't break, and the one outside the suit did. So they made the conclusion that it was you would survive a blast wearing the suit, which was pretty cool. So. As an engineer, you should do everything you can to reduce support, even though you're always required to have it to some degree. All right, so last little segment here. I will say one thing before I play the last video here. Something that didn't make it in the episode, and I just really wish it had. So Jesse took the initiative to take a piece of this titanium, put it in the electron microscope, print out some micrographs, laid them out in the lab. And we're kind of in between takes and milling about, and we drag Adam over, and Jesse starts explaining what he's seen, the microstructure, both in the titanium and in the plastic parts that we were making. So he's like, wait a minute, so by additively manufacturing this, you get better properties. I'm like, yeah, you get a refined microstructure, and it can improve the performance of your material. So then he filmed a little segment of just him talking to the camera, and he used the words refined microstructure and improved properties. And I was like, oh my God, please let that get in the episode, and it didn't. However, he was on Neil deGrasse Tyson's podcast, Star something, I always forget what it's called. So Adam was talking with Neil about this, and they were debating which engineering materials or design is the more compelling, future, what would make the greater impact, advancements in materials or advancements in mechanical design. And deGrasse Tyson said materials, and Adam said design, and then he said, oh, but by the way, in my Iron Man episode, I learned that the process actually modifies the material and it makes it better. And so I did get a little satisfaction that we taught him some knowledge. So, good stuff. So final little segment here.
I just say, when we started down the path of this project, I had no idea how elaborate it would get, and I really did not expect this material, the 3D printed titanium, to perform so well, be so resilient, and to have these incredible material properties that it is continually demonstrating.
So that's it. It was a reasonably small team, excluding all the production crew. Austin from EOS in Austin is on the left in the red jacket. Jen is next to him, and Marcos and John, those are the three builders. So I got to spend a day with the build team out in California while Adam was training to fly. These people are phenomenal. They can build anything out of anything. They're a combination of engineer, artist, craftsman. They can weld, they can cut. I mean, if you needed to put something together, they could figure it out. So it's fun hanging with them. Richard Browning's in the suit, dying because he's sweating and it's pokey and it hurts. And of course, Adam. So with that, these are the other people involved. It was a lot of fun, and happy to answer questions. Yes, one in the back.
Before we can get back to work every day.
It might be a while. So the technology is there. The cost might be a factor, and the safety is definitely an issue. So. Yes.
So over the entire build process, as a manufacturing professor, how much do you think it would cost to manufacture that first suit?
No, it's a great question. In fact, Adam asked me that same question when he was on campus. He's like, what is this, like $60,000, $70,000? I was like, ooh, you're way off, right? So then the education of EOS lost track of how many builds they run. I think Austin estimated 15 to 18. Imagine each of those is in the $8,000 per build range. You know, factor in my time, students' time, everybody's labor, material cost, everything that factors into it. The first suit, if I was going to bid on that, would be probably a nice round number would be $500,000. If I were going to do it again with all of the sunk non-recurring cost of manipulating CADs and fixing them and all the builds, now that we have a strategy, the next one gets cheaper, right? So the next one is still probably $250,000. So I was kind of hoping Robert Downey Jr. would reach out and ask me to build him one. So I already had these numbers in my head. 'Cause that's what
So it's a 30-pound suit?
The metal is less than 30 pounds. The other bits and pieces, I don't know if they ever weighed it when it was complete, but we added a lot of, you know, just simple aluminum straps that were used to hold rivets, and there's a lot of plastic. Turns out the 30-pound limit they gave me was not accurate. The thrust on that suit, the combined thrust is 340 pounds, and Richard is nowhere close. So if you combine the weight of the flying suit, the rocket and the fuel and everything, plus the suit, plus the body, it can't exceed 340 pounds. I think we had plenty of margin, but I think it was probably in the ballpark of 30 pounds.
Okay, so who has it now? Who owns it?
Adam has it now. He has it's either one of his tested shows on YouTube. It shows him building a little display for it, so it sits in his lab in California. I've asked Marvel, actually asked the executive producer if he could contact Marvel and see if I could make you know, the helmet or some other piece that I could put on display in the lab. But I signed a very, very strict non-disclosure about what I can do with those files.